So we've talked about sequences, now we're going to talk about series. So if I have an infinite sequence, the sum of the sequence is an infinite series. So infinite series is the sum of a sequence. And we write it as the sum as n equals 1 to infinity of a sub n. And so if I want to say a partial sum, or I could say the sum is I equals 1 to infinity of a sub I. Doesn't matter what the letter is for your subscript. However, if I want to talk about, I could talk about a partial sum. So that tells me when n is less than infinity, right? So I could write it as s sub n, that the nth sum is the sum as I equals 1 to n of a sub I. And if my sum converges, so if my sums, because I have a whole bunch of sums when n is 1, n is 2, n is 3, if that converges, so if this converges, then I know that my this converges. As n gets bigger, this goes to infinity here. So I call my limit s. Okay? And that is, the limit s is that sum I equals 1 to infinity of a sub I. And then similarly, if this would diverge, then so does that as well. It also diverges. A special type of series is a telescoping series, and where I have terms like this, it would be b1 minus b2 plus b2 minus b3 plus b3 minus b4, and so on. And notice what happens. These cancel out, and they keep on canceling out. So it gives me my sum, my nth sum is b1 minus that n plus 1 term, because this, if n is 1 here, and this is n plus 1. This is n. So that would be what it equals.